Okay, kids, welcome to the first lesson of the Tutor Week. We are moving on from where we were, which was where? What, Faris?
NEA.
NEA, what part of the NEA?
Circuit analysis.
Very good, circuit analysis. Remember that we were looking at 3 different circuits that other people have made and how they could be useful in our circuit that we're producing. Now, we're moving on from that and we're going to the next part, which is circuit design. And I think some of you have already sort of started bits and pieces of this, which is absolutely fine, but I just want you to know exactly how I want the page laid out, which for me is really important because I think it includes all the information. So let's just give ourselves the page, which is a bit messily drawn actually. So this is a piece of, oh, I'm not liking that at all. That's better. I reckon about down there. Right, it's our page. What's the first thing you're going to do, Paul? Sorry? Add a genie?
A title.
Oh.
Very good, the title. Let's start off with the title. And it's going to be circuit design. And probably what we want to do, thank you Faris, we're going to probably put 1. Yeah, because it's going to be the first of, if you're wanting sort of mediocre marks, you probably want to do 2 and a final. If you want the best marks, you'll do 3 and a final. Yeah? I'm saying we need to do 3. It's up to you. Circuit design 1. So, on circuit design 1, I want you to start off by the title and then what?
Introduction.
Oh, you're on fire. Intro. On this page, I'm going to be looking at a design, my first design for a circuit. I've got to make sure, Faris, I've got to make sure that it shows the number between 1 and 6, and I can get 5 different results in 10 seconds. Whatever that sort of rough design brief is. Yeah? Are you with me?
Yeah.
Yeah. You also may want to explain exactly what you're doing with this particular circuit. Okay? So you might just want to, with a few words, explain what you're trying to do. Especially when we go into later editions of this and how one iteration is changing to the next iteration. Do you get me? On the last circuit, it wasn't very successful because it took a long time for the program to load. It took, let's say, the LEDs came on, but they weren't bright enough. The buzzer sounded, but no one could really hear it. Therefore, I'm going to introduce more different components like a transistor or something. Are you with me? And that will hopefully increase the sound. And also, if I use a different program, hopefully the program will be faster. Are you with me, boys? You look a little bit switched off at the moment, like you're not quite here.
Is this just for the circuit and not the program?
This is the whole lot. I'm going to go through the whole
So
lot.
the circuit and the program in one slot.
I'm going to go through the whole lot today. Yeah. Okay. Next up. No. So we're going to just put like a line along there. This is you explaining it there, yeah? What's the last thing we want?
Conclusion.
Thank you very much. I would suggest a conclusion
PSPs.
is done. PSPs.
You've already done
no,
this.
no. We could do client comments.
Okay, conclusion, right at the bottom. Just concluding what we have learned from this page and what we're going to do on the next page. Are you with me? Sure? Right. Now there's these things called concept sketches. Now concept sketches feature in the mark scheme. So what do we want to include in our study?
A drawing.
Concept sketches, yeah? And a concept sketch is not necessarily something that's right. It's just an idea. So first of all, what I want you to do is produce a really rough pencil sketch circuit. Alright?
Pencils.
Sketch. And then take a picture and whack it in. And I'm really happy for you just to a few lines, and I'm really happy for this to be fundamentally incorrect. Because I would say that is your first, or maybe even your second iteration in regards to, we've got an idea, we've put that down as a little concept sketch, now we've got to work on that bit better. Alright? Next up, we're going to put in something called a system diagram. What is a system diagram? James?
It has inputs, processes, and outputs.
Yeah. So now, and a lot of people like to do some sort of funky sort of thing like this.
What do you mean by system diagram?
So a system diagram has the inputs. So what's the input, do you reckon, for this?
PTM.
Yeah, very good.
It's
So
basically,
so Faris, just expand on that. What happens when the PTM is pressed?
when the push to make is pressed, it activates.
It doesn't activate, does it?
It signals the genie.
Right, it doesn't signal genie. When the PTM is pressed,
Pulls down.
and not no, it doesn't pull down.
Or pulses.
Okay, pulses. What happens to the genie when you press a push to make button?
It connects the current to the
Yeah,
pin.
one of the legs,
Oh, yeah.
one of the input legs. It's really that simple. When I press the push to make button, one of the input legs on the genie goes high. That is it. That's what happens to the input. The process would be something like when one of the input legs goes high on the genie, I'll write a program so that three outputs go high in consecutive order. Yeah, whatever it is, whatever you're going to be doing. So you don't have to actually, say D1, Q3. All you've got to do is roughly explain what's going on with a few words. Yeah.
Like a sentence or two.
Sentence, yeah. Process. So once the input thing goes high, I'm going to write a program that does this, and that will hopefully control that. Outputs. What's the output going to be?
So what if we did this for circuit analysis, where we explain what each part does?
Well, you've already done that in circuit analysis. What you're saying is, this is what I'm going to do because this is what I'm trying to do with this page. So if you're trying to make an electronic dice, for example, which shows 3 different results in 10 seconds, it may be that the input will be a PTM, and the process will be create a random number between 1 and 6, and then depending upon that number, illuminate a configuration of 4 different outputs, which are linked to a series of different LEDs. Are you with me on that? I said that quite fast. Faris, are you with me? Put that pen down, please, Faris. Okay? You with me on this? And then the outputs, we're going to go back to that electronic dice example. What would the outputs be?
7 segment.
No, electronic dice, what we made.
Oh, LEDs.
LEDs. A series of different LEDs will come on depending upon what number's been randomly selected. Are you with me? Are you sure you're with me? With your faces, you're not with me. Inputs, processes, what's going on in the genie, and the outputs, how we're going to control those outputs. Sure?
Yeah.
Happy?
Yep.
What's next? Right. Next up is the bit that you'll be more familiar with, and that will be in the middle here on Circuit Wizard. I want you to create a working circuit diagram. I've got CW down there, yeah? Circuit Wizard. So this should work, guys. And of course, you've got on here your Genie 14, and you've probably got an input going in here somewhere, and you've probably got a series of different LEDs. Maybe one of these is going to, like a buzzer or something. Okay? That is our circuit diagram. Are you with me? And you're familiar with this because you've done this for your last project, and you also did it with the DICE project. So you're really familiar with that. Okay, so is that the page finished? Not quite yet. I'm going to do this in blue. I think probably it'll be better done in red. What I want you to do is circle part of the circuit. For example, do you know what that is or not?
What buzzer?
Well done. Well done. I'm going to take it down here.
What is really?
And I want you to explain exactly how your circuit is working. Okay? So here, I would probably think, and we're running out of room a little bit, we do something like that. You with me?
Yeah.
Explaining how it works. Now, if your circuit is very similar to your previous circuit, for example 2, 3 or 4, then you just have to highlight the areas that you've changed. Mohammed, are you with me? Is that gum nice in your mouth? Spit it in the bin, please. Right, are you with me? Oh, Paul, you're not with me, are you? You're with the words. Come on. Focus, just a little bit longer, alright? Because then we've got a record of this. I can put it on the team, and you can do it every week.
The circuit diagram is the actual circuit diagram, not like a pencil. Right?
No, this is the one from Circuit Wizard.
Okay.
Circuit Wizard, yeah? TW. Circuit Wizard, circuit diagram. Okay? And this is just some writing explaining what's going on. Now, what else do you reckon you might need on here?
Client feedback.
Ah, yes, well done. We also need a program. Yes?
Yeah.
You with me? Now, what's the problem with having our program here?
It's probably too big.
Sorry?
It might be too
No
big.
space.
What, the program's too big?
Yeah.
Yeah, totally. The likelihood is we can stick our program in here, but you're not going to be able to read it, are you? That's like it. But I would like to see your program in there, no matter how big or small it is. The other thing I want down here is I'll do a drawing of it.
CAD. Finished product.
Oh, come on, it's not a bad drawing.
I have no idea. So, a QR code.
Yay! QR code.
For
So
what?
I want a QR code down there.
A full
What
form.
is that QR code linked to? That QR code is linked to a video of you showing the virtual model of your program. So we're going to get this working. We've got the circuit diagram. No guys, come on. We've got the circuit diagram. We've got the program. We can get this running on the computers. Are you with me? We then take this home, we show it to our client, and it's really good if we can see a picture of our client looking at this on screen and us saying, what do you think of that? And she may say, I think this is fine, but I'm not too fussed about there just being one button here. And how do you turn this circuit on and off? And wouldn't it be better if there was like another button that I could roll a result between 2 and 12 or 1 and 12? Yeah? Alex, what's the problem here?
I'm confused.
I'm not going to be able to do this until the weekend.
Totally, well, it's not due until Monday.
It-
Now
it's-
there's also an issue of how do I send this to my client when my client lives in a different country? Is that issue? Gordon?
Yeah.
Is that the issue? So what I would like very much is for you to have this on screen and for you to explain what's going on and then send the QR code over to your client. They can look at it and they can give you some feedback. Okay? So you can be explaining what's going on and then you could have either an audio file, or maybe another QR code of another video, or
You take a
even
video.
just some writing. Paul, good sleep?
No.
Yeah. Right. Okay, so are we good here?
Yeah.
So do we see there's a lot of stuff packed into this page?
And we do it 3 times.
I want you to do it twice this week. Okay, I want 1 and 2 done this week. I want 3 and 4 done next week.
Wait,
Alternatively, if you
one,
want,
two.
you can just do 1 this week and do 2 and 3 next week. 2 and 3 being 2 and final. So I want 3 of these done in total.
3 of what?
Harris, what?
Exam 30, right? Well, I need to do the client.
So this is number one.
You don't
I
know
want-
those.
I want circuit design 2, and I want circuit design final, or circuit design 1, 2, 3, and final.
Okay.
Is that clear?
It get different circuit designs.
Is that clear or not? Right. Last thing, boys, last thing. We've got a problem, and what is the problem here? Well, it's this, isn't it? This is the big sort of problem, programming. We can't actually see what's going on. You are asked to show your design skills, okay? Now, with electronics, it's not as much drawing, so we've got to show design skills a different way. Do you design a program?
Yeah.
Yes, it's program design, isn't it? Absolutely. So what I would like is, of course, I want 4 of these pages, but I also want another page where you're explaining, and I don't mind if this is 1 page, 2 pages, 3 pages, I want you to explain your program and I want to be able to see the functions. So that means your program, I'm just going to put PR, program 1 is on the first page, program 2 is on the second page, program 3 is on the third page. I am fine with that, absolutely fine with that. But I want to see the program. I'm not going to just call it programming, am I? I'm not going to call it programming because is there any marks in the NEA specification for programming? No. So what is there marks for?
Iterative design.
Brilliant. Oh, they're both words. Programming, design,
Iteration.
plus iteration. Yes. Are you with me? So 1, 2, 3, and this. I want all of this work due in, not Monday. I want it due in a week on Monday. All right. So, yes.
Can we put all the programs on one slide if they fit?
Yeah, you can. I don't mind if it's, so if you could do that, split that, for example, and that could be your first program, whatever, and then you can show you get the modifications, highlight them, highlight the modifications, what's gone on, a little bit of explanation on the first one, and then you did the third one. Absolutely fine. Equally well, I know that some people, like Frank, for example, has an absolutely enormous program. So we're going to put that on one slide.
He's
and then I think
generating.
he's going to have to. He's made something smaller, so he's going to have to just do.
It's like 800 combinations. It's
Alright.
massive. It's terrible.
Questions, guys. Conclusion comes at the end. Paul, how you doing? You understand?
Yeah.
Sure?
Yeah.
This is what I want you working on this lesson, okay? This lesson.
Alright.
Mohammed, I'm going to turn this off now. Stop it. And then we're going to